it's not a clone of Earth. But for the first time, planet hunters think they have evidence of a planet about Earth's size that could have liquid water in orbit around another star. Kepler-452b, the outermost world of a 5-planet system, orbits about 3 times closer to its star than Earth is to the Sun. But that star, Kepler-452b, is an M-dwarf. It's much cooler than our bright Sun. So, scientists of the SETI Institute at NASA Ames Research Center are confident the new world is in the so-called habitable zone of that star. M-dwarves live very long lives, plenty of time for possible life forms to develop and evolve. M-dwarfs also tend to flare more than our Sun, but Kepler-452b is thought to be at a safe distance, and the enhanced radiation might possibly speed the mutation rate of organisms, driving nature's evolutionary tinkering there. This planet, discovered using the transit method by the highly successful Kepler mission, is only about 10% larger in diameter than our planet. So it's thought to be a dense and rocky world, like Venus, Earth, and Mars in our own solar system, which hold atmospheres made of gases released by their own volcanoes and water collected from impacting comets. Planets larger than about 1.5 times Earth's diameter begin to draw atmospheres made of hydrogen and helium, like our Neptune and Uranus. And they keep on puffing up, like our Saturn and Jupiter, and even growing much, much larger into what scientists call super-Jupiters. Gas giants are not conducive to life on their surfaces, if they even have solid surfaces. No one knows at this point what the surface of Kepler-452b is really like. If there is water, it could be frozen, because the planet is pretty far out in the star's habitable zone. But being larger than Earth, it might hold a thicker atmosphere, which could keep the temperature up and the water liquid. As for the possibility of life on Kepler-452b, that may have to wait for a future generation of telescopes. The planet is about 490 light-years away. We'd likely need a powerful space-based instrument to detect oxygen, ozone, or methane in its atmosphere. Seeing those gases in abundance would likely be the products of biology, life as we know it. Of course, there is a small, but not unrealistic chance that intelligent life could have evolved there. And an even smaller, but still valid possibility that they are, or were, transmitting radio signals now detectable by our technology. Specifically, the SETI Institute's Allen Telescope Array, which has, in fact, begun making wide frequency range sweeps of that part of the sky. For Space.com, I'm Dave Brody. And if you have a question about all this, tweet me at DavidSkyBrody. Space.com.